Okay, this is part 3 of our atmosphere series. First part was talking about the composition of the atmosphere. The second part was completing your layers of the atmosphere flipbook. And this is our third part, talking about energy in the atmosphere, where it comes from, and how it works, how the greenhouse gases then can contribute to something called global warming, which is what we'll be talking about today. If you would open your books to page 36, that's page 36 in your red weather book, then we can get started talking about energy from the sun. So open your books to page 36. Okay, so let's go ahead and get started. Now, electromagnetic waves are forms of energy that can move through the vacuum of space. So electromagnetic waves are forms of energy that can move through the vacuum of space. Now, these electromagnetic waves are classified according to wavelength. These are classified according to wavelength. Now, radiation is something that you probably have heard of before. And radiation is a direct transfer of energy by electromagnetic waves. Now, most of the energy from the sun travels to Earth in the form of visible light and something called infrared radiation. Infrared radiation. And there's just a small amount that arrives as ultraviolet radiation, which is another type of radiation you have probably heard of. So just a small amount arrives as ultraviolet radiation, but most of it arrives as visible light or something called infrared radiation. So let's talk about the visible light, which is one of the ways that energy travels to Earth from the sun. So visible light includes all the colors of the rainbow. So visible light includes all the colors of the rainbow, like red, orange, yellow. Try to write in yellow. Could you tell? Okay. Yellow. There, you can see that better. Green. Blue. And violet. Okay, so these are all the colors of the rainbow. Now, it used to include indigo, which was a true shade of blue, but scientists have started to exclude indigo. One way that I learned in school how to remember the colors of the rainbow in order was Roy G. Biv. Okay, so that includes indigo because you have red, orange, write this out on your paper, yellow, then you have green, blue, indigo, and then violet. Okay, so Roy G. Biv is how I always remembered it. You can still remember it that way, but know this, scientists have started to exclude indigo. So these are all of the different types of light that you can actually see that are considered visible light. Now, red and orange light have the longest wavelengths. So these are the longest. Okay, so up here where you have Roy G. Biv, let's write longest. Over here by this end of the spectrum where red and orange is located. And so blue and violet, they have the shortest wavelengths. So write shortest over here on this end of that spectrum. Okay, so they're going from longest to shortest. So we know that blue and violet have the shortest wavelengths. Okay, so that takes care of all of the visible light that you're actually able to see. It goes along the spectrum, Roy G. Biv, from longest all the way to shortest. And if it's longer than red or orange wavelengths, then you can't see it. Or if it's shorter than blue or violet, then you can't see that wavelength either. So that takes us to talking about non-visible light. Okay, so infrared radiation has wavelengths that are longer than the red light. So infrared radiation has wavelengths that are longer than red light. So you can think about it. Infrared, it has that red part. You know, oh, this is going to be longer than red. Okay, it's on that end. So therefore, it is not visible. But it can be felt as heat. You also have something called ultraviolet radiation. And I'm sure you've heard of ultraviolet radiation and UV protection, and that's where why you want to wear sunscreen. Well, we all know that that's because the ultraviolet radiation is given off by the sun. So this is another form of invisible energy. You can't see these UV rays that are beating down on you from the sun because it's invisible. Because these wavelengths are shorter than visible light, than that violet light. There's violet wavelengths. So underline violet here. Okay, it's shorter than those violets. We know ultraviolet is ultra short. Okay, ultraviolet is ultra short. Let's write that out to the side to help you remember that it's invisible because it's shorter than that violet wavelength, the violet light. That's why you can't see those UV rays given off by the sun. Now, we know that this radiation can cause skin cancer, and eye damage, and also, you know, sunburns. And you know that if you get too many sunburns, that could give you a higher increase of having skin cancer. Okay, so let's move on to talking about more of the energy in the atmosphere and what the Earth does with all this energy that's coming into the atmosphere. So the Earth, we know, absorbs 50%. So the Earth's surface absorbs 50% of the energy coming in. Now this energy is used to heat the land and the water. So it heats the land and the water. And all of the water on Earth's surface, well, we know from studying the water cycle, that's called the hydrosphere. So write that down on your notes. Okay, we're going to be looking at page 38 in your book, figure 2. That's going to be very helpful for you to figure out the rest of this diagram. This is what your art or your figure that you're looking at should look like. It's telling you in each of these captions, if you look at your text feature, how this energy in the atmosphere is absorbed or reflected. Okay, so we said 50% of Earth's surface absorbs energy, and it absorbs it to heat the land and the water. Now, some absorbed energy is then radiated back into the atmosphere. Okay, and about 20% is absorbed by gases and particles in the atmosphere. About 25% of incoming sunlight is reflected by clouds, dust, and gases in the air. By clouds, dust, and gases in the air. Then you have just 5% that is reflected by the surface back into the atmosphere. Okay. So when Earth's surface is heated, which we said 50% of the energy in the atmosphere heats the land and the water. So when Earth's surface is heated, it radiates most of the energy back into the atmosphere as infrared radiation. Okay, so this infrared radiation, it can't travel all the way back through the atmosphere back to space. It's stuck. So instead, it's absorbed by water vapor, carbon dioxide, methane, and other gases in the air. So this infrared radiation is absorbed by the water vapor, carbon dioxide, and methane, as well as other gases that are in the air. Now the energy from the absorbed radiation heats those gases, because we said that infrared, you can't see it, but you can feel that heat produced by the infrared radiation. So when these gases are absorbing the infrared radiation, it heats those gases in the air. And these gases, it forms a blanket, so to speak, around Earth that holds heat in the air, and that's called the greenhouse effect. This is called the greenhouse effect. Okay, so what is a greenhouse? Okay, here's a picture of a greenhouse. Okay, so here's a picture of a greenhouse. It's showing you that it's made out of glass because the sun can shine through, and the heat is entrapped inside the walls of the greenhouse, inside the glass, which makes the temperature inside a lot warmer than it would be outside. So we can have plants that are growing during the winter time because the sunlight is trapped and it causes those gases to warm, which is why when the infrared radiation can't get out of the atmosphere, is trapped inside, it can't go back out into space, and the gases that we have floating around, like water vapor and carbon dioxide and methane, absorbs that infrared radiation, it causes it to warm the air. So we get that blanket, and that's why it's called the greenhouse effect. And that's what helps us actually be able to live on Earth because, well, it's not as cold as outer space would be. So we're going to stop there, and then we're going to continue on to another part. And we'll talk about global warming in that last part of this section.